Today I have Joe Luzin. He's a friend and a co-author of mine. He's a former consultant, now a senior solutions engineer at C&H Industrial. He's my mentor. He has saved me from many technological tragedies by being totally dogged about chasing down problems that would have made me pull my hair out. He also taught me a great deal about Azure Functions, which is why we're here tonight. This is the beginning of a series of podcasts, videos, and blog entries. We're going to start with Azure Functions, move on to durable functions, and then we'll see where we go in terms of talking about APIs, which gives us an opportunity to endlessly plug our book. Joe, how are you?
Good. I'm doing very well.
Really glad to have you here. And I'm going to dive right in. Maybe you could start grounding us with what Azure Functions are and why we care.
Yeah. So how do we put this? Azure Functions in general, it's Microsoft's solution to a lot of things, whether that be APIs in general or runtime environments, consumption hosting model with serverless style, anything in between. Triggers, of course, are a big part of that as well. Listening to individual service buses, queues, HTTP endpoints, so many more. Kind of wrapping that whole thing up in a singular package and providing a number of different hosting options for your platform.
Okay, let's zero in on some of the things you said. Let's start with contrast. There are APIs that have an endpoint, and when you hit that, you run code. But Azure Functions are different from that. They're an alternative to that. Is that fair?
They can be. I guess I would think of them as a superset of that aspect. So, with the HTTP endpoints being a subset of that, yeah. So you have a much wider range of responding to events of some kind, whether that be network events or we've got the classic timers in there as well. You could connect it to things like service buses, as mentioned, to react to changes to any kind of things, blob storage uploads, anything you can put a service bus message on for.
Okay. And aside from flexibility, are there other advantages of using Azure Functions? For example, if I'm trying to decide between, okay, I'll create an ASP.NET endpoint and attach that to a method, or I'll create an Azure function for the same purpose. Why would I choose one over the other?
Yeah, I mean, ASP.NET is great. It's been around for I don't even know how many years now, and gone through so many iterations. And it's an amazing platform that solves a lot of problems. Use it constantly. Personally, basically every day, essentially, right? So it comes ASP.NET comes with a lot of stuff out of the box, including various methods to route your requests to whichever code you want, whether that be the controllers or the minimal APIs. It has a lot of security aspect to it that can be plugged in and configured and tuned. So yeah, that's a really great one. But then contrasting that with Azure Functions, right now there's some overlap in between there. There's Microsoft has done some work to integrate them a little bit. I'm looking forward to seeing that continue to be more and more combined there. The Azure Functions with the HTTP endpoints, they don't have as much rich binding or security or pipeline management or pluggability for the pipeline itself. If you wanted to plug in certain things into the ASP.NET request pipeline, there's extension points to do that. But for like Azure Functions, it's you have access to that, the HTTP request, but there's not a long pipeline per se that ASP.NET gives you. But that's to say, it does give you some stuff. So you have to set your configure your routes and your parameter binding, your model binding somewhere. So Azure Functions does allow that it does give you that opportunity. Yeah. Um, there's other stuff like I mentioned security before. There are some API key based security options that you can do that come out of the box. But then if you're hosting it in Azure, which is normally the default, then you have other options that you could put on top of that, like the Azure Entra ID authentication and things like that.
So, from what you just said, it leaves me wondering why then would you invest in learning Azure Functions and using Azure Functions if it's less, pardon me, functional than the traditional ASP.NET? There must be some serious advantages to Azure Functions.
Yeah, so that's a great point there. One of the big selling points for Azure Functions, and we'll get to the durable aspect later on, is with the Azure Functions, Microsoft gives you a lot of out of the box trigger support for listening to endpoints, for reacting to certain events, database row changes, things like that. Whereas ASP.NET, you certainly could do that, but it would take some extra effort on your part to get that all set up.
I find that sometimes I'm using an Azure function and I'm not really conscious that that's what I'm doing because there's no orchestrator, and we're going to get to orchestrators in a minute. But you watched my listener that picked up messages off the bus and did some work. Would you classify that as an Azure function? Because there was no controller. It was
Right.
just, go ahead.
Yeah. That is definitely a trigger. So there would be no controller aspect to that. That is one of the main selling points of the Azure Functions. It's listening to the service bus. That's definitely the classic example that is well supported and has been around for quite some time. So yeah.
Yeah, let's just clarify that what we're looking at least from my viewpoint, is the message bus does not have to say, "Hey, wake up, here I am." The message bus just puts things on the queue, and then the application, which is an Azure function, says, "Oh, there's something on the queue." That triggers it to take some action. You don't have to invoke anything.
Yes, that's true. So with service buses being the connection, let's say, I don't know, connection heavy, I guess you could call it that. It is definitely a push mechanism to whatever happens to be listening, and creating that listener. You could certainly do that in ASP.NET, but you have to manage the lifetime of that listener and dispatching the messages to wherever your code is manually in ASP.NET. So with Azure Functions, that particular aspect is abstracted away from you. So something in the Azure ecosystem, whether that's the libraries or another part in the networking stack, which I'm not entirely sure about, but I need to find out, is that maintains the persistent connection to the service bus, and then dispatches the message when it receives to your code and wherever that may be.
Okay, so that's triggers. Let's go right to the heart of it, which is the orchestrator. Can you talk a little bit about the role of the orchestrator, why it's there, and how come I didn't have to use it?
Yeah, orchestrators. Oh boy, that's a good one. I do love durable functions.
I'm sorry. Orchestrators are only durable functions? Okay. Thank you. That point has to be made as clear as possible because there can be confusion between Azure functions and durable functions. So maybe we should stop before we talk about the orchestrator and just define what a durable function is and how it's different from a regular Azure function.
Okay. So they're different than a durable function. Yeah, like I'm trying to think like how we would do that without getting into the details of the durable aspect of it.
Well, I should say that we're going to follow this up with a blog post that will have code and help people walk through what actually is happening. So we can say at a fairly high level, 60,000 foot overview at this point, and we'll dive into the nitty gritty when we do the blog post itself.
Okay, so I can say something like, yeah, orchestrators and activities um, are only applied to the durable aspect of Azure Functions.
Okay, and what's durable is the state. Is that right?
Right. The durable is the state, so whereas in regular Azure Functions, whether that be a service bus trigger, Q trigger, HTTP trigger, and so on, uh, those are stateless in general. And the durable aspect really adds in the statefulness of whatever it is you're writing. So some type of workflow, some type of long running activity or event or pipeline of independent executions, things like that.
Great. And with durable functions, we have activities, and those activities are essentially work that the code is going to do. But if I understand it right, you never actually call an activity, that's the job of the orchestrator.
Right. Yeah. Activities can only be called by orchestrators. Yeah.
And how does that work? Does the orchestrator respond to a trigger, or what's the entry point mechanism?
Mm-hmm. Yeah. The orchestrator is essentially spun up or called or instantiated by something. What that something is, in general, is usually in the case of when you're using the Azure Function C# libraries, that is, they give you a built-in mechanism, classes for that. And then you can essentially say, I want to start up this orchestrator with potentially, this ID with this input and let it run. Then it saves that initial state that you give it into the backing store, and then and then the orchestrator picks it up and starts running.
And the orchestrator invokes whatever activities it's been told to invoke based on the trigger, based on the data. How does it differentiate?
Yeah, the inside the orchestrator itself, you can run things like activities and other orchestrators, so sub orchestrators. No, in general, no networking in the orchestrators, and why we'll get to later on. But yeah, in general, the usual normal flow is orchestrators call activities and do little tiny bits of logic with the return values from activities to then potentially call other activities.
And are orchestrators running all the time, or are they triggered?
Or are they triggered? Well, let's see. They're not running all the time. In general, they are. What would be a good analogy for that? Well, they would be, I guess, hibernated. Like if you were to take a standard PC here, and it's in a running state right now, right? Like we're doing right now. You've also got the sleep state, which is essentially suspend to RAM, and then the hibernation state, which is take the entire state of RAM and persist it to disk with everything completely off. So much like that, the orchestrators are persisted to disk. All of the state is removed from RAM, persisted to various backing stores, and you can configure that, but we'll get to that later. And then whenever something happens, whether that be something in a queue or a timer, something like that, comes into the durable storage mechanism of Azure Functions, durable Azure functions, then it will read the state from that particular instance, because you can have multiple instances of an orchestrator, or you can have a singular instance of an orchestrator. But it will pick up that state and then instantiate the orchestrator again and set the state into a replay.
As a developer, do I need, if I'm doing durable functions and of course it's writing to a backing store, do I need to be thinking about, oh, when this goes to a second machine or a third machine, I have to do that coordination, or is that part of it, what Azure provides?
In general, that is part of what Azure provides. You do have to be cognizant of certain limitations on orchestrators and things like that. So without getting into too much details, the orchestrators essentially have to be deterministic, and the activities have to be idempotent, right? So there is no guarantee that activities are run once and only once. It will either be zero or potentially more than one or more times. Same thing for the orchestrators. The code itself is technically executed more than once, but that is because if you have multiple await calls in an orchestrator, let's say, it's awaiting an activity response, it will send a message to the backing durable system and kick off the activity and essentially write that state to the backing store and then sleep, as in remove itself from RAM completely. So to get back to its current state, it has to essentially replay itself from the very, very beginning of that instance. So that means, it can be quite a process. So that includes, if there's a for loop in there, it's got to go through the for loop all over again to rebuild its internal state. However, it doesn't have to wait on information or state that it is already saved, from previously run activities. It already has that. So it can read that from its backing store and then continuously builds up its internal state until it gets to the very next one that it says, I don't have any current state for this. That must mean I need to actually do the real call.
Financially, how does this compare with the alternatives?
Yeah, the billing model for Azure Functions and Durable Functions, there's a variety of options you can choose from. I think they just released the newest one that I'm aware of is a flex consumption model. So that is along with regular consumption model. It's essentially you get billed in what's called a gigabyte seconds. So how many seconds of execution time multiplied by the actual memory usage of your running Azure Function instance, both regular, durable, and activities. So you get a number of gigabyte seconds per month for free. Can't remember off the top of my head what that is, but it's a good amount. If you're doing like hobby stuff at home, that will be a lot that you can get started with for free. The other options are there's app service model where you essentially can reserve individual app services, set them to either a single instance or horizontally scale out depending on a variety of factors, and then that will hold and run your Azure Functions there.
I want to, before we go on, I want to capture three definitions from you: deterministic, idempotent, and horizontal versus vertical scale out. So let's just run through deterministic versus idempotent.
Yeah, for determinism and deterministic functions applying to orchestrators. With the orchestrator itself, even a single instance running who knows how many times, the state that it builds up always needs to be consistent, exactly the same as it was just before it called the, let's say, real activity. So in order to do that, it as mentioned, needs to build up its own internal state, again, based on previous input and activities. So while that's building it up, there can't be anything that could alter the flow. If you call this one await method a task over here first, and then call one over here, you can't switch them because then your state might be completely off. So they have to be called in order for the state to be built up exactly as it was prior. So in that way, the actual determinism comes from things like that you can't use in orchestrators would be things like random numbers, real random numbers, um, new GUIDs, but there are workarounds to that. So it provides you certain things like deterministic GUIDs and things like that, which you can use, but actual randomness in general is usually not allowed in orchestrators for
Right.
determinism
Sort of
reasons.
the opposite of deterministic would be random. And idempotent, let's just define that really quickly again.
Yeah. So for idempotent system, um, specifically applying to activities, with them having no guarantee for only once execution, um, the mindset of this is when you're writing this activity, the code you're writing might execute more than once with all of your input values too. So if you're inserting a database record, if you're calling a third-party API, if you're writing to disk, anything like that, you have to make the mindset like this may happen again in the future with this same information, so that when the activity is finally done at the very last time, then it will be as if it ran only once because it does not change between the runs.
They're very close, very connected concepts, and keeping that sorted. But what you've said, well, which one applies to orchestrated, which one applies to activities?
So the deterministic one applies to the orchestrators, and idempotent applies to the activities.
Okay, that makes sense. Let's switch back to you were talking about horizontal fan out, and if you could just talk about what that means versus vertical versus, and how that is managed by durable functions who have to go to a backing store.
Yeah, so the actual scaling aspect can apply to both durable functions and regular Azure functions. Um, there's no real, there's only the standard classic physical limits on how big a, let's say, activity or regular trigger is, right? So you may process images, video, AI stuff inside a real plain HTTP trigger, right? So, and that trigger itself may use up tens of gigs of RAM to do its thing. And then while that's okay, and that should work fine, um, that's where the horizontal or vertical scaling up comes into play. So um, the vertical aspect of it comes into play with um, setting like your various tiers of memory and CPU usage. So increasing it vertically means going up in RAM availability and CPU core count, things like that.
All on one machine.
All in one machine. That's right.
Right.
That's a good call out there.
And horizontal is fanning out to multiple machines.
Right. Contrasting that with the vertical, the horizontal is physically different. We'll say machines, but in reality, it can be other stuff. Runtimes, it can be VMs, it can be real machines. Anything that requires copies of kind of itself doing the same thing um, is the horizontal scaling aspect.
Is it still Azure if you're running it at your own machine as opposed to running on Azure itself in the cloud? Is it still considered Azure if I have a company and I want it on machines in my building?
Let's see here. So, if I recall right, there's some form of enterprise Azure hosted something. There's I haven't done that in a while, but there's some things that you can run on prem, as well as plugins and libraries for like syncing, let's say, Active Directory or SQL Server, things like that. So there's some mirroring aspects there. Not sure off the top of my head what other Azure functions or Azure resources you're able to deploy to your on-prem resources, but the Azure Function Runtime itself does allow you to take that and deploy it to your own machines. So you've got that um, compute ability there, and then you can adjust your backing store as needed. So, but by default, it's the Azure storage account. It comes out of the box, but there's a few other ones like a SQL Server. So you could use an on-prem SQL Server as a durable backing store for a locally hosted um, durable function there. And that's all not to be confused with the I'm going to mess the name up here. The Something like that, the Azure Microsoft Task Framework, something like that. I don't think I got the name right. So that is something completely different, but same conceptually related to durable orchestrators and functions.
Okay, if you're an individual uh, developer and you want to write a program that uses Azure Functions, is it possible to do all that development locally on your local machine under the debugger without having the cost or involvement of Azure itself? And then when you're ready to deploy, have it go out to the server? Or if you're building Azure Functions, are you sort of inherently dealing with the server?
By default, if your code only is contained to um, your own stuff without any third parties or backend databases, or if you're running those locally, for example, then yeah, you can stick with everything locally during development, and then during deploy time, adjust some options or settings, things like that, and then run that in the actual Azure cloud. The same does go for your local debugging as well. If you need to, you can adjust some settings and connect to a variety of environments that you have deployed. So you can debug locally while having the durable backing store be the real one, for example, in Azure.
But if you want to build something that takes messages off the bus, that bus has to be running somewhere. Is that typically running on Azure, and you're paying for that, or is that run locally during development?
In general, yeah. With the service buses themselves, yeah, they are generally in Azure, and debugging those, um, using those are generally pretty cost effective. If I remember right, I think the basic tier may even be free, but don't quote me on that one. But I know it's quite low cost on those. But an alternative to that is, which I've used with many times successfully in the past, is using a queue instead of a service bus. So an actual storage queue, not to be confused with service bus queues, which are technically different there. The storage bus queues are contained within the what's called the Azure, which is the local storage account emulator. So along with that, you get emulator for table storage, blobs, and queues. So you can insert messages into this local queue system, this queue emulator, and then connect to a standard trigger that the Azure Functions library gives you out of the box, and get your messages that way.
And then when you're ready to deploy, what happens?
When you're ready to deploy, you do technically need a different type of trigger, the service bus trigger, which you can have multiple ones and any number of them in your actual Azure function. I like to leave the the storage queue trigger surrounded by if debug blocks. That way, it's whenever it's built in your CI/CD pipeline, it's never the queue trigger is never even going to exist in the output artifacts there. So then your service bus does run there during deployment, and it should pick up messages like normal. The only caveat is if you are going to try this at home, be wary of there's a slight encoding differences between the service bus and the storage queues. So the storage queues can have base 64 encoding, which you can adjust a bit, but in general, that's just something to watch out for.
What else do I need to know about functions and durable functions before we wrap up?
Oh, that is a big topic there. It covers so much. Um, I'd like to say that Azure functions and by extension durable functions, there is no There is no easy button for scaling, for managing workflows in a stateless environment like that, or stateful for that matter. But if there was an easy button, Azure Functions would be it.
Okay, so it's halfway there of simplifying the requirements and fulfilling the requirements, I should say.
Yeah, certainly, and that halfway there is goes a long way. You know, it taking care of just so much things, so many things for you out of the box. You really get spoiled pretty quick when you run Azure Functions, and then have to go back to some type of on-prem thing, uh, or maintaining a persistent connection, or a retry loop that you have to manually implement, something
Right.
like that. So it really gives you a lot.
Yeah, makes sense. Okay, what we're going to do is become, as I said, much more concrete in a blog post or a series of blog posts that will uh, show I'm going to try that again in English. We're going to be able to show a more concrete example or approach when we can show code and when we can walk it through in steps. But this was a great introduction. This was I have, I think, a much better understanding. I hope people listening have a much better understanding of Azure Functions and durable functions and how they're different and what they bring to the party. So this was great. So thank you.
Great. Yeah. Thanks for
And
having me on, Jesse.
we'll
I
be
look
doing a
forward.
bunch of these. All right, Joe. Thanks.
Thanks.